Hey there, and welcome to your personalized deep dive.
Hello.
We're about to jump into some really interesting source material today. It's all about how LinkedIn built their very first production AI agent.
Yeah, it's based on a presentation, gives a real behind-the-scenes look. They talk quite a bit about using LangGraph too.
Right. And our mission here, yours and mine, is to really pull out the key insights from this. We want to get a handle on the actual challenges they hit building AI agents at scale.
Exactly. Inside a huge company like LinkedIn, what breaks, what works, and crucially, what specific tech choices did they make? What infrastructure did they have to build?
And there's some fascinating stuff in here, like why they made this huge shift in their tech stack, the architecture they ended up using, and some, frankly, pretty fundamental infrastructure they built just to make these agents work in the real world.
Yeah, it's going to be good. Should we dive in?
Let's do it.
Yeah.
So first off, what is this agent?
Okay, so the first one they rolled out is called the LinkedIn Hiring Assistant.
Okay, the name kind of gives it away. Helps recruiters, I'm guessing.
Precisely. The main goal is to automate some of the more, let's say, tedious parts of the recruiting workflow.
Right, the admin stuff that gets in the way.
Exactly. So the big benefit, the whole point, is freeing up recruiters to spend their time on, the human stuff, actually talking to candidates, building relationships.
Makes sense. The source material lays out a user flow, doesn't it? How does that work?
Yeah, it paints a clear picture. So a recruiter starts by describing the job they need to fill. They might upload some documents too for more detail.
Okay, standard stuff.
Then the agent takes all that, the description, the docs, and it automatically figures out things like the key qualifications needed.
Ah, okay, so it's doing some processing there, and this is where the agent part comes in. It doesn't just sit there spinning.
Exactly. It does this processing in the background. The recruiter isn't blocked. They can do other things. The agent just, works away. Then when it's done, it notifies the recruiter. And it might provide, say, a list of potential candidates it sourced based on those qualifications it generated, ready for the recruiter to review.
Got it. So it works quietly and just reports back.
Right. And they actually have a name for that pattern. They call it the ambient agent pattern.
The ambient agent pattern. Okay, I like that. So under the hood, what's making this ambient behavior possible? What's the architecture?
They describe it as a pretty standard supervisor multi-agent setup.
Okay, break that down. Supervisor, multi-agent.
Think of the supervisor agent like a team lead or a project manager. It doesn't do all the work itself.
Okay. It coordinates.
Exactly. It coordinates and delegates tasks to various sub-agents, the specialists on the team.
And these sub-agents, they're the ones doing the actual work, like sourcing or analyzing the job description.
That's right. And critically, these sub-agents are designed to interact with LinkedIn's existing systems and services, databases, search APIs, that kind of thing. That's how they can actually do stuff.
Makes sense. They need access to the real data and tools.
Yeah. And they also introduce this idea of skills. They say it's sort of like tool calling, but maybe a bit broader. We definitely need to circle back to that. It sounds pretty key.
Okay, skills. Got it. We'll put a pin in that. But before we get deeper into the architecture, the source talks about something even more foundational, right? A big decision about their core tech stack for Gen AI.
Oh yeah, that's a huge part of the story. It's really about how a big, established organization adapts.
So what was the situation before? What's LinkedIn's usual tech stack?
Historically, and for most business logic, it's overwhelmingly Java. Python was around, but more for like internal tools, maybe some data stuff like PySpark. Not really for core application logic.
Okay, so a Java shop, basically. So when Gen AI started exploding, late 2022, their first thought must have been, let's use Java.
That's exactly what they tried initially, building some simpler Gen AI apps. Basic prompt calls, maybe a little bit of RAG, but nothing too complex.
Sure.
No real memory or multi-step agent stuff.
No, that didn't quite work out.
Well, it hit a wall. The problem was, teams all across LinkedIn were getting excited about Gen AI. They wanted to experiment with more advanced Python libraries, new prompting techniques, better evils, all the stuff exploding in the Python open source world.
Ah, I see. But their main stack was Java, so a disconnect.
A major disconnect. Trying to do cutting-edge Gen AI work, which was happening almost entirely in Python, within a primarily Java environment, it was slow, difficult, sometimes impossible. It really hindered innovation.
Right. The Gen AI world was moving so fast, mostly in Python, and they were kind of stuck trying to bridge that gap with Java.
Precisely. New models, new libraries, new techniques appearing daily. Trying to keep up in Java felt like swimming upstream. It just wasn't sustainable if they wanted to really leverage this stuff.
So that forced their hand.
Pretty much. They realized a few things. One, everyone wanted to use GenAI. Two, the Java-Python split wasn't working for this specific area. And three, they really had to embrace Python to let their teams move fast and integrate all the open source goodness.
And that's the bold bet they talk about.
That's the term they used, yeah. Making the strategic call to standardize on Python for, well, pretty much all things GenAI. Business logic, engineering, evils, the whole production pipeline.
Wow, that's a big shift for a company like LinkedIn.
Huge. And to make it stick, they didn't just say use Python. They built a specific framework to make it the default, the easy path for teams building GenAI apps. Take the guesswork out of it.
Okay, so they commit to Python and build a framework. What does that framework look like? What are the key pieces?
So it's built in Python, obviously. For the communication layer between services, they went with gRPC.
gRPC. Why that?
They liked its streaming capabilities, efficient binary format, good for performance, and the fact that it works well across different languages. Even with the Python focus for GenAI, LinkedIn still has other languages, so that cross-language support is valuable.
Makes sense. And the core logic, what's handling the GenAI smarts?
That's where LangChain and LangGraph come in. They explicitly state that these libraries model the core business logic. They are like the heart of the GenAI apps built on this new framework.
So LangChain and LangGraph aren't just helpers, they're fundamental to the application structure.
Absolutely central. Which, of course, leads to the next question.
Right.
Why those libraries? There are so many options out there.
Yeah, it's a crowded space. What reasons did they give?
They hit on a few main points. First, ease of use. They actually found that even engineers coming from a heavy Java background could pick up LangChain and LangGraph fairly easily. The concepts just clicked.
That's a big deal, right? Getting a large, diverse engineering team up to speed quickly.
Massive. It lowers the barrier significantly. Second, community integrations. Things like pre-built components, agent templates, like a React agent they mentioned. This let them build real, useful apps in days, not weeks.
Days instead of weeks. Wow.
Yeah, imagine that multiplied across many teams. That's a huge productivity gain.
Yeah,
Especially when the field is moving so fast. You need that velocity.
totally. What was the third reason?
Sensible interfaces. Basically, the way the libraries are structured made it easy for them to plug in their own internal systems. Like they could swap out different underlying LLMs, maybe use Azure OpenAI one day or an internal model the next with very minimal code changes.
Ah, that abstraction is key for flexibility and managing complexity, especially at their scale.
Exactly. So, okay, we have the agent's goal, the supervisor architecture, the big shift to Python, and the core libraries, gRPC, LangChain, LangGraph. Now let's loop back to that multi-agent architecture and the specific infrastructure they needed beyond just the libraries.
Right, because running these agentic systems reliably in production, especially long-running ones, must bring unique challenges.
Definitely. They called out two big ones. First, agents just take time. Like we saw with the ambient pattern, these aren't instant request response things. They can run for minutes, maybe longer, asynchronously.
Okay, so they're slow. Potentially, what's the second challenge?
Well, you often have multiple agents or steps running, maybe in parallel. And the output of one step might depend on another. So you need really solid ways to manage the state, make sure things happen in the right order, and coordinate everything.
Sounds like classic distributed systems problems, but maybe with an extra layer of complexity because of the non-determinism of the LLMs.
That's a good way to put it. The AI part adds unpredictability. So to tackle these, they built out what they call an agent platform.
An agent platform. Okay, what's in it? How did they solve the async communication issue?
They treated it as a messaging problem. LinkedIn already has, as you'd expect, very robust internal messaging systems. So they extended those to handle agent-to-agent communication and also agent-to-user communication.
Smart. Leverage what they already have.
Yeah. And crucially, this messaging layer includes things like automatic retries, queuing, stuff you absolutely need for reliable asynchronous processes. If a step fails temporarily, the system can handle it.
Okay, so messaging handles the reliable async comms. What about managing the state, the context, the dependencies between agent steps?
That's where they built a specialized memory system
Yeah.
designed just for agents. It's not just like a simple chat history.
Oh, how is it different?
They described it as scoped and layered. So you have things like working memory for the immediate context of the current task. Then there's long-term memory, which persists across interactions, and even potentially collective memory shared among agents.
Layered memory, how does that actually work?
So as an agent works on a task, the immediate details go into working memory, but maybe key findings or context about the user get promoted to long-term memory. This lets the agent kind of remember things over time, building up context.
Interesting. So messaging for talking, memory for context. How do the agents do things, like actually perform actions? This must be where skills come back in.
Bingo. That's exactly it. The mechanism for agents to act is called skills, and they make a point to say it's different from just basic function calling. A skill can be more abstract. It could be a standard RPC call, sure, but it could also be a database query, running a complex prompt, or even invoking another agent.
Invoking another agent as a skill. That makes a lot of sense for breaking down complex tasks.
Right, a supervisor agent's skill might just be delegating to a specialist agent. And importantly, skills can be called synchronously or asynchronously. Again, handling those long-running tasks.
Okay, so skills are flexible actions. How do agents find out what skills are available? How does a hiring agent know how to source candidates?
Great question. They built a centralized skill registry. Think of it like a catalog or marketplace. Teams across LinkedIn can build a service, define its capabilities as one or more skills, and register them there.
Ah, so it's discoverable. Any agent can potentially look up and use a skill built by a totally different team.
That's the core idea. It promotes reuse, breaks down silos. A hiring agent could use a skill originally built for the sales team if it's useful.
That registry sounds critical for scaling agent development across a big org. Okay, let's quickly trace an example. How do these pieces, messaging, memory, skills, work together?
Sure. Let's take the hiring assistant again. Supervisor gets the goal. Hire an engineer. It knows it needs to source candidates. So it sends a message task to the sourcing subagent.
Via the messaging system.
Right. The sourcing agent picks up the message. It consults its memory working and long-term to get the full context, the job criteria. It realizes, okay, I need to find candidates. This requires a specific skill.
So it checks the skill registry.
Exactly. Queries the registry. Got a skill for sourcing engineers. The registry points it to the right skill. The sourcing agent then executes that skill.
And that skill execution could be anything, right? An API call, another agent?
Could be anything. Maybe it calls an internal search API. The skill runs, maybe asynchronously. When the results come back, the sourcing agent processes them, maybe updates its memory with what it found, and then sends a message back to the supervisor with the list of candidates.
Got it. I can see how the messaging pipes things along, memory holds the state, and skills provide the actions via that central registry. Feels pretty robust. But how do they know if it's actually working correctly, especially with all the moving parts and AI fuzziness?
Yeah, exactly. That leads to observability. They really stress this. You need custom observability specifically for these agentic workflows. Standard monitoring often isn't enough
Why not?
because the workloads are non-deterministic, multi-step, asynchronous. You need deep visibility into each step. What decisions did the agent make? Which skills did it call? How did memory change? Where did it fail? Their mantra was basically, you can't fix what you can't observe.
Makes perfect sense. Hard to debug a black box, especially an AI black box. Okay, so wrapping this up, looking back at their whole journey, what were the big overarching lessons they shared?
They boiled it down to two main takeaways. First, invest heavily in developer productivity.
Make it easy for engineers to build this stuff.
Exactly. The GenAI space moves incredibly fast. If you want your teams to innovate and keep up, you have to remove friction. Standardizing on Python, building the framework, using libraries like LangChain. It was all about enabling developers to build quickly.
Velocity is king, then.
In many ways, yes, for staying current.
Yeah.
But that leads straight to their second key takeaway. You are still building production software.
Ah, the reality check.
Right, all the cool AI agent stuff is great, but you can't forget the fundamentals. Availability, reliability, solid testing and evaluation, handling errors, thinking about the non-determinism, all that boring but essential engineering stuff is still absolutely critical for anything running in production.
So embrace the speed and innovation, but don't throw out the engineering playbook.
You got it.
Okay, that's a really valuable perspective. So we've walked through LinkedIn's experience, spotting the need, making that big Python bet, picking LangChain LangGraph, and building out that crucial infrastructure. Messaging, the layered memory, the skill registry, it's quite the blueprint.
It really is. A practical look at taking these advanced AI ideas and making them work reliably inside a major tech company.
And thinking about that layered memory they built, It really makes you wonder, doesn't it? How does having systems with working memory, long-term memory, collective memory, how does that change how we should even think about designing intelligent systems that need to learn and maintain context over time? It feels different.
It does. And connecting that to the skill registry, what happens when an organization's technical architecture with these discoverable, reusable skills starts to mirror or even drive how teams collaborate? Does it naturally break down silos simply because the tools encourage sharing capabilities? That interplay between tech structure and org structure is fascinating.
Yeah, definitely some deep questions to ponder there. Food for thought. Well, this has been fantastic. Thanks for bringing these sources and walking us through them.
My pleasure. Always interesting stuff happening.